Welcome to this presentation and discussion about event sourcing and CQRS with IndexedDB. So that sounds like a bunch of words. What do they mean? Well, we'll get into this into the talk. So first of all, what is the problem that we're trying to solve? Problem is inefficiency. So what do I mean by that? Well, I have this personal finance app that uses Google Cloud Firestore, and it uses Playwright to scrape a bunch of web transactions from different apps like bank accounts and credit card apps. And I have about 2,000 transactions that are downloaded every time I load the personal finance app. And if you know anything about Firebase, you know that there's 50,000 reads per day. So that means that if I were to refresh my application just 25 times, I would exceed the threshold for the free tier. And that's terrifying because I just refreshed the button. I click the refresh button all the time. So I want to wonder if there's a way I can architect my application such that I don't have to worry about page refreshes at all. So the goals are: 1, find a way to cache old transactions, and 2, only request new transactions. But how? And if we think about traditional databases, databases store application state, which means the current state of the application, the latest state of the application. It's easy to get the latest state. You just query for the data. But how do you get the diff between what I have cached locally on the client and the latest application state? Well, to answer this question, let's first talk about what is IndexedDB. So IndexedDB is a web API. It's a browser API. It exists in the browser. If you go to the application tab in your dev tools, you'll see that IndexedDB exists under storage right here and over here. And MDN says IndexedDB is a low-level API for client-side storage of significant amounts of structured data, including files and blobs. Cool. So it sounds like IndexedDB probably is going to work for client-side cache. So I can cache the old transactions. Sounds good. But how do I only request the new transactions? I mean, I don't know how to do that. How's that going to help me at all? Well, to get to that part, let's talk about what is event sourcing. So event sourcing is a subset of CRUD, create, read, update, and delete. Event sourcing is just the create and the read part. And so if we think about it, all mature industries are event sourced. For example, if you're in accounting, you see like an accountant's ledger. It's written in pen. There's no erase. There's no crossing out and whiteouts. It's if you make a mistake, you add a new entry that corrects the previous mistake. Right? There's no way to update or delete the accountant's ledger. If you have an accountant that writes in pencil, that's just a bad accountant. But similarly, you go to the doctor's office and they get your height, your weight, your blood pressure, etc. Are they going to a table in a database and deleting the old data? No. They're going to append the new data. And that way they have a series of data points over time. And if they have to do some analysis on this data, that data will always exist. Similarly, if we have a contract, like a law like an agreement, if something has changed to this agreement, this contract, it's not going to be erased and like someone go to Microsoft Word and edit and then print out a new copy. No, they're going to make an amendment to the contract. And then to get the idea of like what is the current state of the contract, you have to read the initial contract and then apply all the addendums to the contract. And also in finance and insurance, similar ideas, right? So the idea is that event sourcing is something where you do not do deletes, you do not do updates, you simply creates and reads. Well, what does this look like in our code? Well, the idea is that in application state, you store your state. But in here, we're storing our events. So all event source systems store the events. You go to the doctor's office. Well, what was the date of the doctor's office visit? What was the data? What was the blood pressure? What was your height? What was your weight? And from these events, we can generate application state. So more concretely in my application, we can look at the types of events that I have in my personal finance app. I have 3 types of events. The first is, one of them is called transactions added. And this is an event that's created when Playwright is going to scrape a bunch of transactions. I have the type of the transaction is called transactions added. The date is a number. This isn't very important. We'll get to that later. And the transactions is just an array of transactions. The transaction updated event is also given a date, and it just has the data is different. So it doesn't have the same shape for every single transaction. Like every single event doesn't have the same shape. But this one has just a single transaction, and it's saying, hey, this transaction was updated. We could decide to store the old transaction as well, but we don't really have to, because the old transaction is never really deleted. We're only adding these events. We're only adding these events to the event store. We're not going to erase the old transaction. So if we wanted to say, like, give me a report that says, hey, what are the how has this transaction with this ID changed over time? Well, we could go through the events, filter the events for transactions added and updated, and find the original transaction, and then find how many times it was updated. We also have a snapshot created event, and this is useful for things like your initial state of the application. Let's say you've built an application that is not event sourced, and you're migrating to an event source system, and so you want to get your initial state. Well, this is how you do it. You have an event with your snapshot, and your snapshot represents the current application state at that point in time. In this case, I have a date, which is that's the point in time. File name, which is like my JSON data of a file path to my a JSON data, and then optionally I can have the data in this event as well. So how do we convert the events into state? Well, it's simply a reduce, right? So like we have our events, we reduce over the events, and we're going to get our application state. So initially we have a empty array of transactions, and then we're going to switch on the event type, and we're going to handle every single type of transaction. In this case, for the snapshot created, we don't care what the accumulated value was. We're just going to overwrite that data and say the point, like at the application state in this point of time, is this, right? Is this event data. However, if I have a transactions added, I'll concatenate the transactions that I have here with the transactions that were accumulated in the reducer. And for the transaction updated, I'll actually find the transaction ID that needs to be updated and replace it. And this is okay because this is application state. It's ephemeral. And reduce works well conceptually, but do I want to do this every single time I have a new event? Or do I want to stream this reducer? Like I want to only calculate the latest event for the next event that comes in. I don't want to have to start from 0 and replay every single time I have all these events. So that's what CQRS is. CQRS is saying, hey, let's go find a way to create these read models and stream in the events and only calculate the latest application state based on the latest events that came in. And we'll do that with IndexedDB. So here's a React hook that we're calling use transactions. And what we're doing here is we're making it so that we can actually apply what we learned in this budgeting app. So the first thing that we have to know is that this use transactions hook takes the event, right? What is the event? Well, it's those 3 things we saw earlier: snapshot created, transactions added, transaction updated. One of those, any of those 3, right? But it's not just any event. We're taking the latest event. And so like in this application, this is a Next.js app where server-side rendering, and the latest event is queried from the Firebase server, the database, and then saying, hey, what's the latest one? Okay, give it to me. Here you go, in props. And it's going to return the same thing that a use state would return: the current state and a way to set the state. And we have a use effect, and that use effect is going to be where the IndexedDB magic is happening. Notice that we have a variable defined called old event date, and that's a number, and we'll be using this later. So we have our use effect, and what we're doing here is we're opening a connection to IndexedDB. We can see we have an OpenDB command, like a function that we're importing from some library, and it takes 3 arguments. One is the name of the database, so I'm calling this Sage, and second, the version of the IndexedDB database, which over here we're saying, hey, the event date is corresponding to the version of the database, right? So in my case, like I don't have any offline functionality here. We'll get into that discussion later. But for me, it's saying every event is guaranteed to be having a unique date. So if I can directly correlate the event date with the version of the DB. And we'll talk about more how to do that with offline functionality as well, with multiple clients as well. And then third, the upgrade function. So it's an object, has many functions. One of them is the upgrade function. And this function is ran when the event date version is greater than the previous version of IndexedDB that exists in the browser. So you imagine like the user goes to the browser, they will, create the IndexedDB with some version number, and then some time passes, and then they refresh the page, and now the latest event is having a different date than what corresponded to the date of the event when originally the page was loaded. And so this function will run now. And now I'm saying, okay, I need to store what the old version was, because that old version corresponds to the old event. Cool. So let's look at this when we have the old event date. When this old event date is not undefined, it was initialized as undefined before. But if it's defined now, after running the upgrade function, this code will run. And so what does it do? Well, first we're going to query. This is like an API that interacts with Firebase. It's like a Next.js API that inside the Next.js API, we're using the Firebase admin SDK to query Firestore. And we're saying, okay, give me all the events after this date. And it's very easy to do. You can say in Firestore, say, give me all these events, which is like my document. Give me all these events that are after this date, right? So date is after greater than this number. And so I get that data, and now I have this bunch of events. And for each event, I'm going to create a transaction, database transaction, normal IndexedDB stuff. And I'm going to switch on all of the different events and handle them appropriately. For example, snapshot created. Okay, wipe away all the data and replace it with this. Transactions added. Okay, add these transactions to the database. And transaction updated. Okay, go ahead and update these transactions. Find the ID and replace, mutate whatever you want, right? So this is going to be all mutation over here. Cool. And then after we have all the transactions, we're going to set the transactions, which we have this inside the hook. And we're going to say, give me all the database transactions, and set those transactions. Then now my React state has all the latest state. And if you noticed, we're not going to now query all the transactions every time we refresh the page. What we're going to do is we're only going to get the diff between what existed before and what is the latest. So now if I refresh my page constantly, well, the minimum I'm going to get as per my reads are 1 read. I need to read what is the latest event. And that's going to be minimum 1 read, right? So, but the maximum is like depending on what the diff is between the latest state and what I have in my IndexedDB cache. So let's look at our goals again. Okay, cool. We can cache all transactions, and we can only request new transactions. And bonus, performance. Who knew that? Like, it's a great performance benefit if you don't have to requery all the entire data from the beginning of the universe for all of your application state. And there's a ton of benefits for an event source system as well. For example, like you can have a really, really easy way to get reports on your data, like because you're not losing your data. Your data is never lost. So you can do all kinds of, reports and analysis and, change your application to use those events if you didn't use them currently. Like, for example, one example that is commonly used is you're building a e-commerce application and you have a user who is adding some item to their shopping cart, and then before purchasing, removes one of those items in the shopping cart. And now you can say, give me a report on saying, okay, find me all the users who have, right before they checked out, 5 minutes before in that time, they removed an item from their cart, and now go send them like an advertisement for those products, right? So like, how would you do that if you were to not store those events? Like if you forgot about, if you didn't know up front that you wanted to do this, it'd be really hard to do this. But if you're using an event store system that says, okay, cart added to item added to the cart, item removed from cart, purchased with all these dates, you can do that after the fact. You don't have to even know that you want to do that until later, and it still works. And I also learned a very useful pattern in a safe environment. This is a side project of mine, which was a really great place to learn all this stuff. If you want to learn more about IndexedDB and service workers and offline applications, there's a great course on Udemy created by Jake Archibald and another person as well. It's called Offline Web Applications. Really, really good stuff over there. And then more about event sourcing. Learning Domain-Driven Design was the book where I learned this. Also a bunch of YouTube talks by Greg Young. Thank you so much. So now we're going to the discussion portion of this. Welcome, my brother, Ramin. How are you doing?
Pretty good.
So you have a problem, which is you have an application, you have tons of data, and you have a client that's saying, hey, how can I avoid requesting all the data constantly every single time I refresh the page? But you do have a cache, and that makes sense. But how do you know what was the diff between your current cache state and your application state? Does this help in any way?
Yeah, of course. It makes it a lot more straightforward. Now, that makes it a lot easier to work with than just using Firestore.
Any questions? Confusion? What's some point of something that doesn't make sense?
It seems pretty straightforward. The only thing that I didn't realize before was, going to use two separate database technologies, one for the snapshot essentially, versus using Firestore to make it your latest updated source of truth, which is a good idea. I like it.
Yeah, so Firestore is your event store. It doesn't have to be Firestore. It could be any database, MySQL or whatever. You store your events. That's your persistent your state. Like your IndexedDB is ephemeral. If somebody deletes it and then refreshes their page, they're gonna get all the data. It will use more data, of course, but they'll get all the data. They'll use more. They'll make more reads, but they'll get all the data. And you can delete it and have no worries. Like that data is ephemeral, right? Whereas like your events, you need to persist that somewhere. So it could be Firestore, it could be somewhere else. We talked about like how would this work with an offline application. So we know that Firestore gives us the feature of syncing offline. So what does that mean? That means that like if I am on my phone and I go through a tunnel and I was gonna do something that would save to the database, normally the request would just fail, and whatever that state would have been saved is now lost, right? Unless you save it and then retry or some kind of custom thing like that. But Firestore gives you like a out of the box support for doing this automatically. Whenever the network is resumed, then that request will be fired off, and you will get that state saved in Firestore. That's super awesome, because if you think about, hey, how can you do this in an offline application? Well, one, all you have to do is store the data in IndexedDB and store it in Firestore using the normal Firestore APIs, because you're storing the event. And if IndexedDB has the event already, it's not going to be requested next time you refresh the page. It's going to ask for the latest after that. Now you can ask yourself, hey, what if another user did the same kind of save, and then now you have to refresh the page and Now, in the way I did it, of course, it wouldn't work out because now the event is like, is like you're saying after this date. Well, what if before that date there was some other data that I'm not pulling now because as a result I didn't have that? Well, there's a many things you can do to figure that out. So maybe you maybe have a flag on it, like saying like, okay, was this red in the database? I haven't fully thought through all the different gotchas over here, but let's imagine that there's a way you can say, okay, let's say if you have a flag, okay, this is received by Firestore. Like maybe you have like a function that every single time Firestore is updated, it adds a flag that says like, okay, I read this, right? And maybe you need to make sure all your events have been received. And then if you're saying, give me the latest date, well, give me the latest date only for the ones that have been received, right? And so, okay, what about duplicates? There's some things to think about there, which I haven't fully got into. But the idea is I fully believe that event sourcing allows us to solve a lot of these problems much more simply than what previously existed, which is you're storing application state. How do you sync the two application states? You're going to re-download a bunch of stuff. And how do you make the diffs between the current cache and the latest application state easy to understand? I think it's going to be challenging without some kind of event source system.
Yeah, you could easily make the database unique for each user if you had something like that, if you wanted to store the databases locally.
Well, I mean, for your application, but for I mean, there are other applications where you want to share the data between different users, and they can write to the different they can write to the same data, offline or at the same time. One thing that's interesting is like conflicts. Like typically, if you're in like a SQL, like a normal application state kind of database, like MySQL, where you store normal application state, you would really worry about the overwriting someone's data. Let's say I have a customer invoice, and I'm editing the name of the customer, and I edit it to John, but somebody else edits it to Joe. Only one of those will win in the end, and I have to decide. Some kind of logic will say like, okay, is John the name or is Joe the name, right? Or is there it's a conflict mode, and now somebody has to resolve this manually. Well, in an event source system, you have no data lost. So you could just say like whatever the latest one was is now the latest, the latest in the event. And I can look at a history of that customer and say, okay, what were all the different names? And maybe okay, if there's two events that are within a certain time interval, maybe flag to the user, hey, which ones, you could easily say like, hey, which do you want to take a look at this because maybe there's some issue there, or just say like, hey, if there's a problem, there's a history and you can always go back. But the point is there's a lot of problems that were fundamentally hard to solve. I think event sourcing makes things so much easier. Now one question is well, what if I have billions of events, right? And they're constantly growing, right? How am I going to handle all these different events if I want to get my application state? Well, like we talked about snapshots, you can snapshot your application state to a certain point in time and use that as your initial state. So you can I have this billion events. Well, I'm going to squash it down to a single snapshot, which has a bunch of application state in the form of, let's say, JSON data or something. And now I don't have to go through all those different events, but also I can have instead of having my read model in IndexedDB, I can have a read model on the server. Give me an API that will give me the latest application state. You can still do that with event source systems. That's the normal way of CQRS that's the normal way. Hey, I store my events, they're persisted, my application state's ephemeral, but it's not only on the client, it's available for everybody, and it's the latest application state. The normal way to do that will be have this data accessible via an API.
All right.
Should we wrap it up?
Yeah, I think so.
Okay. Thank you for listening.